I did that all before it started recording. So that's good. It's not now made part of my impressive YouTube channel. Okay, review a little bit from yesterday. We'll talk about that in a minute. Construct some formulas using proportional and inversely proportional. And let's do it. This, again, is a problem that you might see on the test. Again, I haven't gone over it yet, but I'm going to do a recording, maybe during work time, while you guys are fiddling around with inverse and direct proportionality. So we'll get to that in a little while. Let's talk about this. Inverse and direct proportions. Y is or varies directly or is directly proportional with x if there is a constant k such that y equals kx. Geez, so like, what does that even mean, right? Are you thinking that?
Yeah.
What does that even mean? All it means is a linear relationship. Example, let's say your income is based on the number of hours of work. How do those relate? They relate directly. Let's say you make $12 an hour. Oh, I take 12 times the number of hours I work, I get my income. Of course, that's not accounting for taxes, which would basically put you down at about $8 an hour. Okay, direct proportion. What does that mean? That means that the income will go up as the number of hours goes up. That's direct proportion. Or your income will go down as the number of hours goes down. All right, so they are directly related. Okay, inverse relationship. If there is a constant k that exists such that y equals k over x. Do I have a good example of this? Oh boy, I think we'll just get to one here in a moment. Let's see here. Let's hop down to Boyle's law. Does anybody know Boyle's law? From science? All right. A constant temperature. At a constant temperature, the pressure P of an ideal gas is inversely proportional to its volume. All right, so pressure P is inversely proportional to its volume. Yeah, T over V, right, at a constant temperature. So as long as T stays put where it is, it doesn't change, that constant temperature, the two will vary inversely. So as the volume increases, what happens to the pressure? Decreases. Or as the volume decreases, the pressure will increase, as long as the temperature is the same. So we could say over here, P equals T over V. All right, the third example is joint proportion, which means that now there's just a second variable involved. Okay, but all that would mean is that, you know, say for example, we've got, well, z equals k is our constant, whereas x and y are variables that can change. Let's look at a couple more examples here down below. So Hooke's law, the force F exerted on a spring is directly proportional to the extension of the spring. So that would be kx. Kx, directly proportional. Do we know what k is? No. That probably has some implications on maybe the thickness of the spring. That's probably where that constant value comes from. Okay, let's look at another one that I'm pretty sure you're very familiar with from the old geometry days. Am I right? Okay, volume of a right circular cone varies jointly with the height h and the square of the radius. Okay, k, which is our constant, times r squared h. Does anybody remember what k would be in this situation? Pi, right? So volume is pi, oh really, yeah, pi r squared times h. That's the volume of a circular cone. And actually, I think we got a third somewhere in here. If it's a cone, it's 1/3 of the cylinder that encloses it. So the constant would be pi over 3. Okay, last one. The current I through a conductor between 2 points is directly proportional to the voltage. Okay, so let's just put a constant in there. Directly proportional to the voltage, so we multiply by V, and inversely proportional to the resistance. Boom, done. So directly means it'd be in the numerator, right? Inversely means it'd be in the denominator. Therefore, we get our relationships there. All right, so here we are. We're going to graph. We're not going to graph. We're going to use a, what do I want to call it? A number line. Yeah, that's a number line. And I'm going to test some values around specific values, right? What is the one thing you always want to be careful for regarding a denominator? Can't equal 0. Can x squared plus 1 ever equal 0? No. Sneaky. So there are no vertical asymptotes or holes in that rational function. Are you with me? So there's no vertical asymptotes or holes. Okay. So what's the next thing I want to do whenever creating a number line? I want to know where, let's say it equals 0, right? Would you agree? I want to know where it equals 0. In this case, I don't want to know where it equals 0. I want to know where it equals 1. But we're going to equate that to 0 in a moment. So I'm going to ignore this thing for a moment, this denominator. I'm going to ignore it, and I'm going to write this as 3x minus 1 is, let's say, equal to 1. I want to know where it's equal to 1. Okay, so I'd solve that algebraically. I'd add 1 to both sides. I'd get 3x equals 2, so x equals 2/3. Anybody disagree with that? Okay, so we're solid there algebraically. So there's only one place that this function will actually cross this axis, right? It's going to cross at x equals 2/3. Okay, so what should we do next? I want to know where this function will be greater than that, excuse me, less than or equal to 1. So I know where it's equal to 1. It's equal to 1 at 2/3, but I want to know, is it less than to the left of that point or to the right of that point? So I'm going to pick nice numbers. What's a nice number I could pick to the right of 2/3? 1 is typically a nice number. Why? Because when you multiply by 1, it doesn't change anything. So let's test 1. Let's test it. Let's test it. Let's see if it'll be positive, excuse me, if it'll be greater than 1 or less than 1. Okay, so I'm going to plug it in. If I plug in a 1, it looks like I get 3 times 1 minus 1, which is 2, over 1 squared 2. Uh-oh. Did I do something wrong there? Let's pause. Okay, I forgot something here, and it happens, even to those who are JV. I can't just ignore this x squared plus 1. I can't, and here's why. What we've got to do is we've got to multiply both sides times x squared plus 1. All right, so it cancels it here, and now I get 3x minus 1 is less than or equal to x squared plus 1. Ah, here we go. Okay. So how would I solve that? Well, I'd try to get everything on one side. So I'd get x squared minus 3x plus 2. Ooh, much better. And I want to know where that's greater than or equal to 0. What is your favorite 6-lettered F word? Foil has 4 letters. Factor. Yeah, factor. Okay, can I factor that? Let's see. X. Oh, I like a minus 2 and I like a minus 1. Oh, no wonder 1 came out to be 0. I stumbled upon that very greatly. Okay, so here I am. I've got my number line. I'm going to test. I know that these values, this will equal, it will equal 0 at 2 and at 1. Of course, there wouldn't just be one value you'd have to test around. We got to test around multiple values, which I would probably test 0. I would probably test 3, and I'd probably test 3 halves test those three values. Let's plug them in and see what happens. If I plug a 0 in here, I get 0 minus 1 and 0 plus 1. Will that be positive or negative? Will negative 1 over 1 be positive or negative? Obviously negative, right? So I'll get a negative value here between those two. I think it would probably be a safe idea to assume that this out here, anything to the right of 2 will be positive, but we should check. And I think it's pretty safe to say that this will also be positive, but we should check. So let's plug a, oh, shoot. Look what I did. Nobody even stopped me. I tested 0, right? So I'm going to assume that the middle one will be negative and this one will be positive. But you still should check just to be a good child. Typically, they alternate. Typically, it goes negative, positive, negative, but not always. So let's just check in case. So let's go ahead and test 3 halves. Well, algebra. So if I test this by plugging in 3 halves here, what's 3 times 3 halves? Well, that's 9 halves minus 1. So that'll be 9 halves minus 1, which is 2 halves. So that'll be 7 halves. And if I take 3 halves and I square it, and I add 1, that'll be 9/4 plus 4/4. Okay, will I get a positive or a negative in the numerator? I'll get a positive up here. Will I get a positive or a negative? Positive. So a positive over a positive is a positive. Okay, so feeling comfortable? Better now that Mr. Ludd didn't fail you? Okay, cool. How about the third one? Let's plug in 3. Let's see what happens. So I'm going to plug in a 3. So I get 3 times 3 plus, minus 1. That'll be 8. And 3 plus, 3 squared plus 1, which will be 10. Ooh, that's a positive. So it was good that I tested this. It was good that I tested it because it looks like I get positive here too. So let's write out an interval for this. Where would this function be less than or equal to 1? Well, it's equal here. It's equal here. And it's less than here. So how would I write out an interval? Negative infinity to what? To 1. Closed or open? Closed. Union. How do I write just 2? 2 to itself, right? So I could write it like that, but I'd have to include brackets. And that would be the interval at which said function, gross, Eddie, this is for you. This is for you, Eddie. Yeah, I know. It makes that purple look brown, which just suits your team so well. Yeah. Okay, this would be the interval at which this would be true. Right? From negative infinity to 1, as well as at just 2. As well as at just 2. All right, so as I begin this problem, I'm going to write out my number line. What are the values that this can't equal? Well, not yet. What would make the denominator 0? 3 and what? Negative 3. So I'm going to consider that I have asymptotes at negative 3 and at positive 3. Okay, now the next thing I'm going to do is I'm going to set up an equation or an inequality. I'm going to take negative x cubed plus 4x over x squared minus 9 greater than or equal to 4x. And I'm going to multiply both sides by the denominator on the left. And I do that in order that, what would this be? Distribute. I'd get a 4x to the third minus 36x. Now I'm looking for those points where they would equal, right? I could write this as an inequality, but really what I want to do is I want to find out where they're equal. And those will be my other points that I'm going to test around. So this is going to be kind of fun, right? I got myself a cubic and a linear term. So I'm going to bring everything to the right. So that would be 5x cubed. And if I bring this 4 over, I'm going to get a negative 40x. Oh, you're so nice. You're so nice to us, Mr. Ludd, because I can take out a 5x. So I get x squared minus, oh, gross, 8. Okay, this one's nasty, folks, because your favorite 6-lettered F word, factor, is not going to be all that nice. But what you could do instead of factoring is just solve, right? What would x have to be in order for this to be 0? Oh, I know over here this would be 0. Oh my gosh, this is a terrible example. Well, x squared would equal 8, so x would equal the square root of 8, but there's actually 2 values there, plus or minus square root of 8. Okay, here's where it gets really ugly. So I got 0, square root of 8, negative square root of 8. So 0, you would agree, is right here, right? Square root of 8, is that greater than 3 or less than 3? Less than 3. And negative square root of 8 is just a little bit greater than negative 3. So, okay, I'm not going to do this, but here are the intervals where you'd have to test values. How about negative 4? How about some value in here? How about another value in here? How about another value in here? And here? And here. You'd have to test 6 values. Ew! Gross. No, Alex, you won't. Although if you really wanted to punish your brain algebraically, you could. Let's see what I got on the key. I'm interested. I want to see this. And those of you at home, I want you to see just how ugly this is. So that is a gross one. Ah, there it is. Here we go. And I'm past my 15-minute limit, but that's okay because I'm verified. All right, is this going to really do this? Come on. E.T. E.T. Maverick. Zelly. Mommy. Daddy. Janice. Daisy. E.T. E.T. Close your eyes. E.T. and Maverick go night, night. Like, subscribe, comment. All right, sorry for that terrible singing. So here we go. You would have to test all of those intervals. Now, I'm not going to be that mean on the test. However, how come I can't scroll? Scroll. Scroll, child. Okay. Apparently, it doesn't have its grippy gloves on. Okay, but I got -3, I got +3, I got 0, negative root 8, and positive root 8. I'd test values around them, and I'd see, in this case, we've got some alternating true and false. This is true for me instead of positive or negative, depending on what it wants. This is false, this is true, false, true, false, etc. So there would be your interval. Yeah, it's good. It's a lot of work. Obviously, that one is. The ones that you can see the answer for the next one will have no solution. That's interesting. But you can analyze, diagnose. Oh, there we go. Now it's moving. Okay. And then I'd like you to jump into the word problems as well with a neighbor. Don't forget quiz due tonight, midnight. Peace.